In this presentation, we're going to look at Way Anova. And so what we're going to do is we're going to do this through R, and then we're going to have a look at interpreting the output. So what I'm going to do here is, first off, we're going to assume that we have 3 fertilizers to be tested, okay? And we wish to determine if there's any difference in means for the 3 types of fertilizer. Okay, so here we have 4 samples for each type of fertilizers, 4 observations. Fertilizer A 5.6, 6.4, 6.6, 5.8, and so on. Fertilizer B, likewise fertilizer C. Now, if you're familiar with this type of stuff, you might sort of see that this would actually might yield or might lead into a second type of procedure, and that's correct, but that will follow in a future presentation when we look at 2 different factors together. But anyway, we're only looking at one factor right now, fertilizer A, fertilizer B, fertilizer C. And this is the data that I'm going to use. So I'm going to set it up like this first off. You could turn it into a data frame, but in the meantime, it'd work perfectly fine just to if you're not that familiar with R yet, that you can actually just set up the data set as fertilizer and set up yield. Okay. Now the thing about it is you have to have, let's just do this, fertilizer and yield, let's just put them in together. So there's R. Okay. So we have fert and we have yield. Okay. Now you can probably see that the first outcome here corresponds to that, the second outcome here corresponds to that, and so on. So it's for each of these values here, we can find the corresponding category membership up here. Okay, now there is a little matter to discuss. First off, the class of fert. This is a very useful command. It's a character. Okay, so it's actually not a factor. So what we have to do is and actually, let's just go on further to that. So this is not a good way of running this procedure. Yield by fertilizer. Okay. The reason is that fertilizer there is currently constructed as a character. So let's clear that. There we go. Now, what's going to happen here is this is not the best way to do it. Okay. What we have to do here is it'll sort of work in this particular instance, but but in general, it's not the right way to do it. What we should do is transform fertilizer into a factor. Okay, sorry. So factor and fert and levels equals A, B, and C. Okay, so that's a fact. That's turning it into a factor. Okay, so levels A, B, and C. So this is a better way of doing it, essentially. Okay, so we'll run this procedure again. Let's clear that. So we're going to run this procedure again. Now, it didn't really matter that time round, but it's when we just had it as a character data and didn't transform it into a factor, but it's just better to have it as a fertilizer. So this is the summary, okay, and so what we have there is between group and within group. So here between group corresponds to fertilizer, and within group is residuals, the source of variation. So it's either, you might call it the within group, residuals, or error. What we're interested in is the test statistic there at the end, 0.42. Okay, so what is this test statistic about? Let's just write it up here. So that's an old one there. Hang on a second. That's an old one there as well. Let's just get a new one going here. So so the null hypothesis is we can write it like this: mu of A equals mu of B equals mu of C, where mu is mean yield. for each of the various fields. So mu is the for each group. That's mu, the Greek letter. So the average of A for fertilizer A is equal to the average of fertilizer B, and that's equal to the average of fertilizer C. Another way of putting that is no significant effect for type of fertilizer. Okay, so the type of fertilizer you use doesn't really change anything. Okay, so no significant effect for type of fertilizer. Okay, now what we're going to do here is we will look at the p-value, and in this case the p-value is going to be right here at the end, 0.42. So p-value indicates not significant result. Oops. So it's not significant. Failed to reject the null hypothesis. So failed to reject. So what we're saying is that according to this data, we can't detect any difference between the types of fertilizer in terms of how that affects the yield. Okay, so that is Way Anova, and we'll move on to another example there.